Good morning, Doctor. We are from Group 11. Today, we are going to present about our group project. Our topic is electric circuit and the subject is Mathematics for Engineering Technology 1. Our group members consist of me, Mackenzie, Kurt Ming Teng, Tan Po Zeng, and Muhammad Izzat Firdaus bin Roslan.
Okay, my name is Muhammad Izzat Firdaus bin Roslan. I will talk about the introduction. Electricity is the cornerstone of modern civilization, powering industries, homes, and the technologies that define life. One of the foundational concept is the flow of charge or or electric current. When a conductive is connected to a power source such as a battery, the charge within the conductor move and create the current. This project aims to provide the comprehensive exploration of this core is called the principles supported by derivation and real world examples.
Thank you, Izzat. Now I will present about the methodology. First, electric current I is the time rate of charge, eh, rate of change of charge measures in ampere. A charge Q is an electrical property of the atomic particle of which matters consists, measures in column C. Third one, time T, is the duration it takes for one complete circle of a waveform to occur, measures in the second S. Mathematically, the relationship between current I, charge Q, and time T is I is equal to dq over dt. First one, power P is the time rate of expanding or absorbing energy, measures in watt, W big W. And second, energy small w is the capacity or to do work, measured in joule J. Third one, voltage or potential difference is the energy required to move a unit charge through an element, measures in volt V. Mathematically, P is equal to dW over dt equals to dW over dt times dq over dt. So the formula is P equals to V times I. So I will pass to my friend Dan.
Thank you, Kirk. Now I will explain about the example. The charge that entering the positive terminal of an element is Q equals to 5 in 4 pi T millicoulomb, while the voltage that across the element from plus to minus is V equals to 3 cos 4 pi T voltage. Now the example wants us to find the power that delivered to the element at T equals to 0.3 seconds. Now I will pass to my teammate Mackenzie to explain about the solution.
Thank you, Tan Po Zeng, for explaining the example for me. Now, we have the equation for charge, which is Q equal to 5 sine 4 pi t millicoulomb. And now, in order to find the equation for current I, we will use the formula I is equal to dq over dt, which is to differentiate the equation of Q. And we will obtain 5 cos 4 pi t times with 4 pi. And by combining those terms, we will obtain the final equation for current I, which is equals to 20 pi cos 4 pi t milliampere. And now, according to formula, power P is equals to voltage times with I. And we have the equation for both of those terms. So by substituting the equation, we will get P is equal to 3 cos 4 pi t volt times with 20 pi cos 4 pi t milliampere, and we will obtain the final equation for power P is equal to 60 pi cos square 4 pi t milliwatt. And by substituting the value of t, which is equal to 0.3 into the equation of power p, we will obtain 60 pi cos square 4 pi times with 0.3 milliwatts. And the final value for power p is equal to 123.37 milliwatts.
That's all from our group. Thank you for your attention, doctor.
Thank you, Doctor.
Thank you, Doctor.